All right?
Yeah.
Okay.
So let's go.
I am recording. Are you also recording or?
No.
Oh,
You're
okay.
recording. So
Exactly.
let's
Yeah.
go through the system then. You say
Yes.
we have attributes. An attribute is an entry point.
Exactly. So the entry point, it can be used like a GPU value, right? But it is not set at the beginning, right? It's like a placeholder, basically, the attribute. So at a certain time, it will deliver a value, right? But when you connect the graph, it is not returning a value. So like text code or a semantic or a GPU in, these are like inputs that are defined. But the attribute is not yet defined. You know, you still have to say how the value is delivered. And in this system, it will be delivered by a resource. You know, so it will be a buffer get, for example, or read from the texture. Yeah. But we don't know how from the beginning, because to know, we need to know the complete graph. Because, for example, like if it's a structured buffer, we want to first collect all the attributes and then set up the buffer, define a struct and everything. Yeah. And then, so we need kind of the graph, yeah, to build the resource, but also the resource to kind of build the graph. And so we do it in 2 steps. Yeah, we build the graph with these placeholders, build our resources based on that,
and then inject the
placeholders. Yeah, and this is a basic concept.
Yeah.
The idea, the motivation. Yeah.
So this means that I can't connect one attribute to compute systems, right?
You can.
Can I?
Yes.
But if they have a pointer to something.
Ah, yes, you're right. Not compute system, compute stages. I was misled. Yeah.
Okay.
But you can still use, so like here with position, for example, you could take it, right, and connect the same attribute to another compute system.
Yeah, definitely.
And then, because this is its own instance. Yeah.
So if I have a certain set of nodes that I patched, they represent a nice simulation for my particle, I want to use this part also in another particle system. I need to duplicate those node set, right? Instead of connecting the same.
Yes, so you could not take this position and connect it to the input of another.
Because that position really, it's an entry point, but it's a pointer to a resource of this system. Okay. Well, let me just turn off the water on the fire. Okay. I see.
Yes.
Okay. Okay.
Yeah. Okay, so I would suggest now we look into the attribute first. Yeah, to see how this entry point handling is done there. Yeah.
Yeah.
Okay. So you see, I mean, I guess this is quite sure, right? We have our attribute node, and we can basically set it up and create our own kind of little process node. And we can say, give it a name, a group, yeah, and some more information like the type or if it's buffered. And then it's set up. Now, if we look into the attribute, you see that here is a reference node, right? And from this reference node, yeah, you can, this is also like a shader node, although the value is not yet set, right? So it returns a GPU value so that the graph can be evaluated, but it doesn't write code that is working yet.
Mm-hmm.
Yeah. And
so the attributes are passed to the system as resources, right?
Exactly. So,
okay. So everything is a resource, basically, in the graph.
You can also have a GPU in or semantic, and it's not a resource. Yeah, but all the attributes are linked to resources. Or in case they are not buffered, they are not even a resource. They would be an internal variable in the GPU in the shader.
So semantic is not a.
Or let's say it's not like from a buffer or from a texture, right? So a semantic is a resource in terms of it provides data, like the text code or the position or whatever is set to the semantic.
So could we say that the attributes are resource descriptions, basically?
Yes.
Okay.
Yeah, I think we can say it like this for now.
So they are basically the models that you consider that you need to collect and consider in order to build the actual resources of your system.
Yes.
So they are mainly resource related, and not just model, because they also give you access, help functions, and they give you access to the resources.
Yeah.
Okay.
Yeah. Okay. So, and what you see here is we have this reference node, and yeah, we create an attribute reference here. Let's look in there. You see, and this has like all the stuff we need to kind of replace the content, right? So you see, you can set the graph here. Yeah, you can also get the graph once it's set.
But which graph is it? Shader graph.
This is a shader graph. So basically, this is not yet set. So you have to inject something, a small shader graph, which makes like the read from the texture.
Okay.
Yeah. Which is not yet connected, and this way allows us the system, to connect it.
Yeah. So it's not really a generic shader graph. This could be renamed. I don't know. Resource sampler function, something like that.
Yes, but on the other hand, we also don't. Yeah, it could be renamed, but we do not know how complex this graph will be. So this is really like a placeholder in this time for any kind of graph, right?
Yeah, but the main, since we say that attributes are mainly related to resources, that's the function that is used basically to access the resource, right?
Yes. We can call it data provider graph or whatever, that is more descriptive.
Just to understand better, to contextualize this.
Yeah.
Okay. And get attributes graph is the graph is basically to get the
to get this shader graph which is set there, like read texture or write.
Yeah, because set shader graph get used when in the phase where we build the resources. There we also describe how to access them, and then anywhere you place this attribute and you want to use it in your patches, you will basically collect this graph that allows you to use this access point to the resources.
Yes, exactly. Yeah.
Okay.
Yeah, and what you see here is, already this add resource is the same like the tooltip, So we add this attribute as a resource, to this shader graph. And then it's kind of set up. Because this is the GPU value that we get in the first version of the graph, right?
Yeah.
And this has this has the resource, so we can query for the entry points at a later stage. Right, like with the tooltip, we can go through the graph and collect all the attributes.
All the attributes, so that we can build the resources.
Exactly. And what we also see here, we have a reference node on top, which is not yet set up, but we have it because it is inside our attribute reference, right? Which we can query. So we can get this attribute reference, and then here in this reference node, set the input graph or like inject the graph that we want to use.
Sorry, I got confused here.
Yeah, no problem.
Why you have the reference node outside and also inside the attributes reference?
So basically, this is the GPU value. This is like the loose graph end. Yeah, this is like what needs to be filled out. This is like where we need to append our.
Okay, because you can attributes reference is not a GPU
exactly
value, so you need to attach it to.
Exactly.
Also, okay.
Yeah. So this one has a reference to this node so that you can attach it later. Yeah. And this is this object. This is really like this specific node, you know, where we will inject our other part of the graph.
Okay. Member is a specific implementation of a kind of attribute, right?
Exactly. This is like storing all the other type, like the name, you know, like the type, you know, so that we know, okay, it's a float 3, for example, because this then reflects back on the resource management, because we need to know, okay, this attribute is a float 3. So then in the struct, we know it's a position of the float 3, and we can add this as member to the struct.
So, but the node member means that, okay, this attribute will be a value that is part of a struct.
This can be a struct, but for example, if you have textures, then it will not be part of a struct. Then it means you will create a texture, you know, read write, whatever is set up of type float 3.
And you will still use the node member.
Yes, the attribute will be the same.
Yes. Okay.
Because this is just you know a class to store information, and even though it's called member, no, it still is kind of a member, just the resources handled differently. I reused this class from somewhere else because it provided already like everything I needed. Yeah, so it came from the struct, but you can use it the same because, as you see, it provides all information for a member: the name, the type, and like, is it buffered or maybe even double buffered.
But why this is a separate node and it's not part of the attribute itself? What's the need of decoupling them? Just because you wanted to reuse this node?
Yeah, otherwise you would have set here the values again. Yeah, and it makes sense at a certain level. You just work with this part of the information. You do not work with the graph. You know, you do not work with a value reference. You just want to get the member information. You know, and then
I would say it's like the model of the attribute.
Yes.
Okay.
Yes, you could say though. Yeah.
Okay. This is some of the runtime that will get basically updated, and yeah. Okay.
Okay, so I think this is pretty much the information that we need, you know, at the one part of the system, at the leaves of the graph, so to say. Yeah.
Yeah.
So this is like with the delegate function, the function parameter and the invoke kind of thing. So the function parameters are on top of the graph, right? With these kind of functions, and the invoke marks the end of the graph. Yeah. And in this case, these attributes mark the leaves in our graph. And at the end of the graph, there is our compute system, yeah, which is what we look into now.
Yeah.
Okay. So let's get into this thing. Yeah. So here we do not have many attributes. Yeah, like, well, we have color here and position and whatever. Yeah. And now we look into the compute system and what it's doing. So let's see. Yeah. So we have this update thing, right?
Yeah.
And here we have the set resource handler, set compute stages. These are mainly put to functions so that they are called in the correct order. Yeah, so if we look into set resource handler.
Which is the dispatcher, sort of.
Yes, exactly. This is creating the buffer, the texture, and whatever, so this is what it sets up. We will look into this, yeah. And this is kind of like an interface thing, the resource handler, which says like how the data structure is created and handled, like gives all the information on how you map the graph and the resource handling to a specific resource. And then there are then you get the compute stages, right, which are the individual compute shaders. Yep. And once this is set, you check if something has changed. And that means, okay, the system needs a rebuild, right?
So if the graph changes, or there is
exactly.
a ticket system to get basically the latest version, and if it's changed, means that you need to rebuild.
Exactly. So you see the resource handler provide tickets, and the compute stages provide tickets. And then you take the maximum and check it if it's bigger than your highest ticket. And that is like kind of the mechanism that you described to me, which now works beautifully, and avoids a lot of bugs so far. Yeah. Exactly. So this is what you check here in the rebuild. If this is true, we know we need to rebuild the system. Yeah. And this means, okay, you go on this if, and you first update the highest ticket, and then rebuild the system. So what is this function doing? This is what we have here. Yeah. So these are like all the individual functions that we call one after the other
when we rebuild.
To rebuild everything. So first we clear everything. Then we
Which means that getting clear the resources and.
Yeah, let's see.
Right.
Yeah. Yes. So exactly, you have a dictionary basically, where resources are assigned to a string. And this is really like the group thing. So if you have, for example, the group particle, then you have a resource for the particle, and then this is where it would look up and reset it. And then you add all the attributes. So which is like what you see here. So you have your compute stage, all the compute stages, and then you set the resource handler. Yeah.
Why do you set the resource handler there before collecting the resources?
Yeah, we can look into this. Let's have a look. Maybe we just stay here at this.
Okay.
And we will come back to it to not get to like come from one level to a deeper, right? Okay, so that we get first a good understanding of. Okay, so and this resources thing, this gives like all the attributes that are on the graph.
Why attributes? I mean, just get all the resources, not necessarily just the attributes, right?
Yes, exactly. Yeah, I think so. Otherwise, I might call it attributes. We could maybe rename it if this is misleading. Yeah, we can look through it together. Yeah. And then you kind of collect all the attributes, which is what you see here. So, and you get a dictionary basically. First, like you want to have the keys. So you want to have like all the attributes so that you can build a struct of it, you know, like just one representation of every attribute so that you know, okay, I have a position, I have a size, and I have a color, for example, right? So this is what you register first, just the information that you have this type of attribute. But then you also want to collect all instances, because this is where you have to inject all your connection shader graph, you know how you get your data from the resource later on. And this is kind of what you do here, right? So you take all the members, you know, where this kind of information is stored, and you put it here to have a description of what you need for this resource.
No, sorry, no. Attributes, so for each attribute, you get the key and the value.
Yes, exactly.
No, sorry, I missed a part. Mutable dictionary string to mutable list. Why is it a dictionary? Sorry, I missed this.
Like in string, there's a group. This string is, for example, particle.
Where is it defined, this string?
Let's see.
Is the group node, you mean?
Yes, this is a group.
Okay. There is this. Okay. So you can basically define groups. Okay.
Yeah, and this is like what you keep. So basically, like all color, size.
It's a way to basically see. Okay, this is a member. This is a position. Is a member of a struct, and this struct is particle. No, so you can. Otherwise, they would be combined into a unique struct. Everything that you really put there.
Yes, exactly. I guess another thing would be to just add them all into one big list, you know, and then separate them later, you know, like query what is your group, what is your thing, but I decided to already place them in a dictionary based on this group ID.
I think it's fine.
Okay. Right, and so this is what we get out of here. We get a key, which is a group, right?
Yeah.
So particle. And then we have members, which are connected to this group. Yeah, so we take the key and then iterate over all the members that we have saved in this for this group.
Yeah.
And then now we are checking. So and like for one map, we look like this is our resource map. This is what we need for the struct, you know, where we just need this one instance, basically. You know, where we just need to look at, okay, I need for the struct, I need this position attribute of type float3. Right? And no matter if I have like 10 position attributes in the graph, I only need this information once to build my struct. Yeah. And so this is here kind of building.
Well, if it doesn't find the group, then he builds this group and add the for each one of them, he builds like a dictionary, no?
Yes, exactly. And then it also kind of collects all the attributes individually. Let's see.
Yeah, basically collects and get basically gets unique members per struct. So
yes. And so what you also see here is that we are also building a connection to the resource here. So we have the resource handler, right? And we have a group, and we tell the resource handler, okay, now create a resource for this.
Okay, so this also is something that is connected to the resource handler and to what we need to implement later, because this resource handler is provided at the compute system, and we might need to override it when we at the compute stage level. So we would need to inject a new resource handler at the compute state, right?
No, I don't think so. Because the resource handler is doing different things. It's doing currently the dispatching, but it's also creating, for example, the buffer or the texture. And the buffer.
Maybe we would need to decouple this though.
Yes, but then there will be something additional, then there will be a dispatch handling or stop, but the resource handler will remain, I think. It will just be the question, how do we place the dispatching?
Yeah.
It might get out of the resource handler and an additional thing, but I think the resource handler will remain.
Yeah, it could be that topic of the viewers, of the perspectives.
Yeah. Because this part has nothing to do with dispatching.
Okay.
Yeah, it has pretty much just to do with, is it a buffer, a texture, or anything else, and how you read from it. Yeah. And then, so now we have add all the attributes. And now we create the resources. And this is what happens here. So we have our map of resources, which the resource handler has created, right? But they are just like a basic instance of this resource. And then here they are actually created or like filled out or whatever. It's kind of a placeholder which collects all the data first, and then here it's like instantiated or whatever you might call it, yeah?
Okay.
And so we need to add all the attributes first, because then we have all the data to create the correct resource. And then now, once we have all the attributes and we have all the resources ready, they are now bound. So the resources that we've created are bound to all the individual attributes. And if we look into there, it's like in here. Okay, and this happens like on compute stage level, because this is like your compute shader. We will look into this now.
Yeah, you basically, you need to propagate upstream.
Yes. And then as a last step now everything is bind, and now we come back to our attributes, where we have this reference node and blah, 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 which is not filled out yet. And now we know, okay, we have set it up. So we read the graph again, because it has now different ends, right? We have replaced stuff in the graph.
I thought that was the bind resources part.
No, the bind resources graph was actually attaching it to the graph, right? But now we need to reinterpret the graph.
Okay.
We have to rebuild the shader. Like here, at this point, the shader is not built. It's just all the nodes are connected.
Okay.
But now you have to take this graph, right, and then actually really build the compute shader from it. So this is thing that will probably get clearer now when we look into compute stage.
Okay.
Does that make sense so far?
Yeah.
Yeah. Okay. Yeah, and I guess you do not need to probably look into everything. It's more, I think what I look into a lot is like the resource handling and the resource handler and blah, blah, blah. Okay. But this is still a good overview. And now we will look into the compute stage. Yeah. So yeah, so if you look into here, you see this is our compute system with compute stage interface. There's this group node also where you can group multiple compute stages and kind of still have one.
Yeah, this is still the old thing that we defined. Yeah, same.
Then we have these attributes where we have talked about. Still need to look into this one class. Yeah. And then this is another kind of topic, this kind of resource handling, which is one other side of it we still gonna look into. But so far we're just looking to apply the graph and not look into how the resources are built. Okay, so compute stage is also explained by one interface, where you see these are like the things like bind resource, you probably remember, get the resources, update the graph, set the resource handler. Yeah, so these are all in this one thing. And now we can look into one implementation of the compute stage. Right? Yeah. So this is like here an update. This is where we get our shader graph. Yeah.
Yeah.
Here you also see get resources of type. Right. This is probably called resources. We could also call it attributes in this case, because this is what we store there, right?
Yeah.
And this is querying, this like tooltip. This is querying because here I have the type set mutable list attribute reference. And this relates to this, and because of this, you get like all the attribute references which are injected into the graph. Yeah. This is where the name resources comes from. It could also be attributes. Yeah.
Yeah, definitely.
And here you also think it is generated once the shader graph is changed.
Yeah.
And what you also see is this is not immediately piped to a compute shader graph, right? So this is something else, the compute shader graph, because this is not working yet, because like there's something missing at the attributes, which is not yet attached. Yeah. So the graph is updated, but then it's forwarded to the compute system, to kind of check it all before this one here is called. And yeah, here you see actually how the compute shader is done, right? So it takes the shader graph here. So this is the same graph object because the compute system has a reference to this graph, right? And is changing it, but they still share the same graph. And yeah, so we feed in this shader graph here into the compute shader graph. Something I think that is not used is the possibility that might be something interesting for the fluid or whatever, that you can build a compute stage, and for all these types of compute stages, you want to append something to prepare something or whatever. Yeah. So this could be a pre-graph. And then in this case, after evaluation, you have this option if you want to write the attributes back into the system. And then this will be also added from the resource manager, which is something we come to.
And we could also have a post graph input.
Exactly. This would be something, if we encounter this, that this would make sense, that there are like compute graphs where we say this is always the same kind of routine and you just want to fill out these blanks, then this could make sense. Yeah. And here you see this is also where we have this get thread group info, and where we might want to inject something different than the resource. Yeah. Okay. So this is the query function for the resources, which is basically like all the attributes that we got from the graph. Yeah, this is basically looking this draw function. So this is like draw, which is called from renderer, right? This is like iCompute stage is also implementing iRenderer.
Yeah.
So you can connect it there. And as you see, this is basically calling this. I just have to check if the resource handler is assigned, because if not, I do not have the information to actually execute the graph. And this is basically just split into two different functions so that it looks a bit cleaner and not too and one too big.
What's the context that is coming into the?
This is the one from the interface.
Okay, okay.
So this is from iRenderer. Yeah.
Okay.
So this is also forwarded here, and there you see it's like I render draw and then so the compute shader graph is actually then outputting a custom compute dispatcher, which can then be which is an iRenderer and can be drawn. And then there's this bind resource also, what you see here. So the resource handler has a way to create a binder. And for this binder, you need to know how to access the ID, right? Because this ID, for example, in a compute shader, this is the dispatch thread ID. This is this int3. But in a render shader, for example, this might be the vertex ID. So, and then it's not the dispatch thread ID. And this is why this bind resource thing is set up in the compute stage. Because the renderer, even if it's not computing, it's kind of doing the same thing. It's executing the shader based on the attributes, but then you would provide a different dispatch thread ID.
Okay, like when you render them.
Yeah, let's have a look in one other. If we look in here, we look in the sprite render.
And this is another implementation of.
Yes, so if we look in the base render, which is the thing that I'm using, you see this is also implemented, right? And it also, for example, has this update graphs thing, right? So for example, here we have to set inputs to our draw shader graph. And here, for example, you see we also get, it's basically the same binding thing, but we provide the vertex ID semantic here, and then take out the XYZ.
Okay, so we still pass XYZ index.
Yes, I'm not sure yet how this is set up in the vertex ID. That would be something to look into. If this is how far this relates to dispatching, or how we have to distinguish between those two cases, right? So that this is probably something to consider also for the views things, But this is also something for textures, for example. I mean, if we can still draw the data from a texture.
Yeah.
Then we would need to see how this relates here, right? What kind of viewer one would need to maybe have 3D chords, and so this might play a role later on. That this might get passed through a view or whatever.
Yeah.
Okay. Everything.
So that's the basic delegate that will be used to collect data from the buffers, no?
Yes, exactly, or the texture. So maybe now we look into the resource handler as the next.
Because the resource handlers contain all the resources.
Yes, exactly. For one compute system. So basically the idea currently is the compute system can only handle one resource. Or like one, like even if it's textures, it is still related to like one number of elements or like one dimension, like in the fluid system, for example, you would say, okay, this is 96 by 96 by 96, yeah, is my volume. And then I have multiple attributes. Okay, I have velocity, pressure, and whatever. And I all store this in different textures. And this is what the system can handle. But if you now have additional information in another resolution, you know, this is then something that you can still do, but this would have to, you would have to specify this all individually. You would have to say somewhere, I declare a texture, and then I can read it, I can write from it, I can write to it, I can read from it, yeah. But this is one crucial thing, and you cannot mix stuff, you know, the compute system cannot handle a buffer and a texture. We could.
Yeah, this is part of the discussion of these thoughts of the viewers. I think it's the dimensionality is something that you can have just one dimensionality, basically. You can have like two different spaces with 3D and 1D at the same time. Then inside that common space, then dimensionality, you can have multiple resources.
You still can just have, or like for example, with buffers, you know, if you have multiple groups, you could, for example, have particle and something else, you know, and then it would have two buffers, but the buffers would be of the same size.
Yeah.
Yeah. And this is a simplification of the system that might something that we could extend, you know, if we come up with solutions on how to deal with it.
Well, I guess that's connected to the dispatch topic also, because if you want to create a shader in which you dispatch, like for, say you have a simulation stage in which you operate on the particles and you use a dispatch for all the particles, then you have another shader in which you want to go through another buffer, which is smaller eventually. There you dispatch for that buffer, no?
Exactly. Like if you give a function, like how you get the data, you know, for the dispatch ID that the shader has, then this is like set up in the attribute, you know, because then the attribute, when the attribute is set, it would basically look into the dispatch viewer or into the viewer or the dispatch information or whatever for this resource, and then it would know how to read out the data from this buffer, even though it has a different size. Yeah. But you see, it's already a lot of different interfaces and methods, you know. So you have the attributes, you have the resource, and all bring this all together. And let's see how we can make that with the view as well. Let's go back to compute. Yeah, so this is the resource handler. Let's look into one implementation of the resource handler. So this is basically pretty simple. It just says like if it's asked to create a resource, it says, okay, then I create a buffer resource, like with this element count. Yeah. So this would then also be something where it could be maybe extended. Then it says, okay, give me your thread group info. Yeah. And this is maybe also something that is taken out here. And then here it is basically saying, okay, create a binder. But as you see, this is also forwarded to the buffer resource binder. Yeah, so we have three actually. We have the handler, the resource, and the binder. Yeah, and the handler is just forwarding these things to the correct implementation of the class. And if we look into the buffer resource now, Yeah, so this is basically this function create resource, right? And here we have all the attributes that we have collected. So you see it's a dictionary of I members. And this is now the individual description, for example, for particle where we have size, blah, 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 right? You know, all these attributes. And so we take these values and create a struct from this. And we store this struct because this is later how we kind of relate to this individual attributes, which we will come to. And we also query the stride of the struct. And then we create a compute buffer, yeah, which is now like the resource, like the backbone of where we get the data.
Yeah.
Yeah, and then we have other things which is more like information, so we can query here the stride of this thing later on from the outside, or we can also get the struct description, where we get a list with all the attribute names and their types later on. Is there anything else? Yeah, and so here you see the buffer resource also has a reference to the struct and to the attributes and to the buffer itself. And this is what we will lead later on in the binder. So if we look here in the resource buffer handler, yeah, this is where it is passed. Okay, now let's look in the buffer resource binder. And this is now where you see it gets a bit more complicated. I think so far it was all just, you know, data types and modeling, and this is now kind of implementation. So here we have still have time?
Chris.
Yep.
Sorry, I need to interrupt.
Yeah.
So shall we continue from here?
Yeah.
Yeah, it's really important. I wouldn't interrupt this, but
No, but I think it's a good point. I think I don't know if you just have one last minute. It's basically, I think, first important thing is just the compute system itself. You know, with the attributes, the compute stage, and the compute system. And I think that we got, right?
Yeah.
So, and I think now the deeper stage is the resource handling, which is like kind of under the hood and is really like the hidden stuff that you want to take away from people, you know, like how this is all set up. And this is a bit more complex. And I think it's no problem if we look at it like more fresh. Yeah.
Okay, perfect. Well, thanks so much.
Yeah, let me know if it's back, and then we see if it fits or if we continue tomorrow. Or let's see.
Perfect.
Right.
Thanks, man.
See you later.
Later. Ciao.